So we learned about cleaning data, connecting tables, building logic, and creating visually intuitive and error-proof reports, right? And
Yes.
today we pivot from the general data analysis to specialized and high valuable field, which is financial analysis, right? So we will use again the clean and structured data environment we have learned to build uh, to answer the fundamental financial questions. So the functions today we are going to learn are the building blocks of the financial models, and they are used to make decisions about loans, investments, and project worth of millions of dollars. So the spreadsheet I already shared in the group. I request all of you to please open the spreadsheet.
Yes, sir.
Okay. So the functions we are covering today are all based on core financial principle, which is the time value of money. Anyone of you is aware of this concept? Time value of money. Have you heard about it?
No, sir.
No. Okay. Let us say it means that a dollar today is worth more than the dollar tomorrow. Let me explain you with the help of example. Okay, so let's say 10 years back, what all things you could buy with 10 rupee?
Hello. Sir, can you
Yeah,
repeat?
10 years back, let's say in 2015, what are the
Mhm.
things you could buy with 10 rupees?
All this means then we can say the basic daily needs things like cookies and we can say uh, other essential goods. But in that time the quantity is means higher side. Now it's the same rate, but quantity is very less. We can say.
Right. So if let us take an example, if you are getting some, let's say 100 gram in in 10 rupees, if you were getting 100 gram that time, okay, but
Yes.
today you hardly get 70 or 60 grams
6 kilo.
in that
Right.
same price, right?
Yes, sir.
Yes.
So what is the effective price of 100 gram today then?
It's near about we can say 20, 15 or 20.
Right. So we want to, so that is something which is called as the time value of money. That is the function. Okay.
Okay. Yes.
So we will explore two categories of this function today. The first one is we call as uh, for loan and investments, which is called as PMT, and which calculates the payment for a loan. And also, then we will talk about the future value, which calculates the future value of the investment. Then we will go into the capital budgeting functions used to evaluate profitability of the project, which is NPV, net present value. Then IRR, internal rate of return. So these functions helps basically businesses to decide if a potential investment is financially viable or not. So let us start calculating payments. So these are a bit technical concept, but yeah, overall you may be aware of this particular thing, especially when it comes to the first function, which is FE function. All of you must be aware of the home loan EMIs. EMI is the very
Yes.
common.
Yes, sir.
So how they are calculated, we are going to learn today. Okay.
Yes, sir.
So if you can see over here on my screen, we have two functions. The first one is PMT and then FV. So basically they are the two sides of the same coin. Uh, PMT is typically used to figure out payment on a date you owe, that is, let's say EMI, and FE is used to see how much an investment you are making will grow. So let us start with the syntax for PMT. So PMT has basically four or five parameters inside it. So the first one is rate, which is of course the rate of interest. So this is the most critical part. So let us say if you have an annual interest rate but make monthly payment, so you generally divide that annual interest rate by 12. Okay. Then there is NPER, which is the total number of period. For example, if you are making monthly payment for 5 years, how many periods it will be?
60 months?
Right. 60 months, because we are making monthly
Yes, sir.
payment for the period of 5 years.
Yes, sir.
Then there is something called as PV, which is present value. It is the total amount of loan that you have taken. So in Excel's cash flow conventions, money you receive is positive. Uh, so the resulting payment, that is payment which you will be giving, will be negative. Okay. So your EMI will be shown in negative over here. Okay.
Okay, sir.
So whatever comes in positive, whatever goes out is negative.
Negative.
Okay. And PV, I already mentioned. Then FV and type are optional arguments. We will mostly ignore them for now. As you have seen, so in syntax, always remember that whatever is mentioned without brackets, so they are compulsory field, and whatever is mentioned in square brackets, they are optional fields. Okay.
Yes, sir.
And after the PMT function, next is FV, which is future value. It calculates the, I mean, by default with the name, we can say it calculates the future value. The syntax is very similar over here. If you can see rate and PR, PMT. Here, PMT is the regular amount you invest. Uh, it is again a negative number, as it is going out of the pocket, and this function tells you the final positive value of your investment. We'll try to understand them in detail with the example that we are going to see. Okay. So let us say we will be calculating the car loan
Car
rate.
loan payment.
Okay. So over here we have, if we see, we have PM. Uh, I mean, when we say PMT, do we have rate of interest? Yes,
Yes.
we have rate of
6%.
interest. Okay, which is 6%. So what we will do is we will divide this by 12.
12.
Okay, because we'll be paying monthly. Then do we have periods?
5 year.
5 years.
Right, we have 5 years as a period. But again, since we are making monthly payments, we'll be multiplying it by
12.
Then do we have a present value? Yes, we have. This is the amount that we have borrowed. Okay.
Yes.
Then we will close the bracket. So
Okay.
this will be our monthly
Thank you.
EMI. Okay. So if you just want to verify whether we have calculated it right or wrong, you can simply you know, multiplied with the periods. So see, we have taken the amount of $25,000 and we'll be paying 28,999.
99
Okay, so roughly $4,000 as a interest we will be paying.
interest.
Okay, clear?
Yes.
Yes,
Yes.
sir.
Yes.
Then uh, let us talk about the other function, which is FV, future value. So let us say you are making monthly contribution as $500, and the rate of annual interest rate is 8%, and investment period is 30 years. Okay, let us see future value. The rate of interest is 8,
8%.
right? So again, we will divide it by 12.
12.
Then next is
Time period.
investment period. Okay,
Mhm.
so we are again making monthly investments. We will multiply this by 12,
12.
and
Mm.
we have monthly contribution, which is minus 500, or rather $500. So this is the amount that you would be getting at the end of 30 years. So let us see how much interest we will be getting on our investment. So how much money we are uh, investing, which is 500. That is for the period of 30 years, and that too monthly. Okay, so let me reduce the distance. So this is the amount that you would be investing, and this is the return that you will be getting. So again, the period is 30 years, so of course the uh, you know returns are more, almost four times the return. Okay,
Yes, sir.
clear? Any doubts? So these are
Mm.
No, sir.
very these concepts we always often come across, but we hardly know how to calculate them, how to calculate EMI, or how to calculate return on our investment. So this is the formulas which you can use to calculate. Now, both of you, please open the spreadsheet. First, try out this T1 example and
Okay.
then T1 practice, and let me know once done. Okay.
Yes. Yes.
This is where the project viability concepts comes into picture. So there are basically two functions. One is NPV and second is IRR. So NPV is net present value. It tells us about what a stream of future cash flows is worth in today's dollars, and after accounting an initial investment, uh, these are the calculations which are done. So the decision rule is very simple. If NPV is greater than zero, the project is financially acceptable, and if it is not, then it should not be accepted. So the syntax for this is NPV, then followed by rate, then value 1, value 2, which is the series of cash flow from period 1 onwards. Okay, so it the second concept is IRR, which is this is the critical note. which you have to keep in mind, that the NPV function in Excel does not include the initial investment, uh, so which is for year zero of cash flow. So you must account it from outside the function. So the correct formula is initial investment plus NPV and then followed by the entire formula. So that initial investment and the initial investment should be a negative number. So this is something we'll see in the example. Then the second is the IRR, which is internal rate of return. So this is another key metric along with NPV. So it calculates the exact discount rate, uh, which is the at which the project's NPV equals to zero. So it's the project's intrinsic rate of return. The decision rule is simple over here. If IRR is greater than discount rate, the project is acceptable. And the syntax is simple: IRR and then values. So over here, the decision rules are mentioned. If NPV is greater than zero, the project should be accepted. If it is IRR is greater than the discount rate, the uh, then accept the project. Now let us go to the example and try to understand this concept. Okay. Okay, let us clean this a bit. Let us do some sanity check before starting the analysis. We have cleaned the data. We have the discount rate. Okay, we'll just make this bold. Get this out. Okay, now so if you can see over here, these are the cash flow for different years. So the cash flow for the 0th year, I mean, whenever the investment is made, it is uh, 1 lakh, then it is 30,000, then 35,000, then 40,000, and so on and so forth till year 5. So now we want to calculate NPV, which is net present value of this cash flow. So how we would calculate it is NPV. Then what is the rate? The rate is 10%. So we would put it as 10%. And what is the value one over here? So again, value one is the investment for year one. So this is the range for different value or different returns that we are going to get subsequently, and enter. So this says 1,28,000 as the value, but the catch is we have to also consider this value, which is 39,000. Sorry, which is the first year's investment, and that has to be negative. So we'll have to subtract this value from here. Let us see what is the answer. Okay, we would need one more. Zero. Got it? So this is how we
Yes.
calculate the thing. Now let us just let me see if we have correctly, inserted the formula. So this rate is 10%, which is 0.1. Then these are the different values. Yeah, this is what the answer which we are getting. Okay, clear?
Yes.
Yeah. Then we also want to calculate the IRR, which is internal rate of return. So it is pretty much straightforward how much internal rate of return we are going to get. So which is IRR, and simply we have to give the
Values.
values. Okay, these are the values, and then it says 21% is the IRR. So the thumb rule is the if NPV is greater than zero and IRR is greater than the discount rate, the project should be accepted. So over here, we were getting NPV as 28,000 and IRR as 24.28. That means the project should be accepted.
Accepted.
Okay, clear?
Yes.
Yeah. Why don't you go ahead and practice this and the other one, and then tell me the result.
Yes.
I'm just verifying the results quickly.
NPV value calculate
Mm-hmm.
and second that IRR value. So I have first calculate IRR NPV value is $5,645,000.
Okay, and how did you calculate NPV?
NPV first of all cash flow plus
Mm-hmm.
NPV formula and rate of discount rate. Okay, 0.12
Mm-hmm.
and select that C2 to F2 and bracket complete.
Okay, so you got answer as,
$5,645.23, sir.
is it positive or negative?
Sir, this is positive, sir.
It is in bracket.
Yes, sir.
When it's in bracket, it is negative.
Okay.
Can you see the result? It is in bracket. No, just click enter. So the answer, the result is in bracket. That means the value is negative. Okay.
Okay. Yeah, right, sir. Okay.
Yeah. And how about the second, which is IRR, internal rate of return?
B2 to F2, sir.
What is the result of it?
Project, sir? 11%, sir.
11%. So now your NPV is how much?
NPV, sir, negative.
What is the value for NPV?
NPV minus, like that, no, sir, minus $5,640,000.
So what the NPV is minus 5,645
Yes,
and IRR is
11%.
11%. So in that case, if the NPV is negative and IRR is 11%, should we accept the project or should we reject it?
NPV. Accept the project, sir.
Accept the project.
Yes, sir. NPV is the greater than zero. No, rejected, sir. NPV is less than, sir.
Right. The NPV is negative. That means we cannot accept the project.
Yes, sir. Reject the project, sir.
Okay.
Yes, sir.
Got it?
Yes, sir. Sir, one thing, sir. When I just show that all the example and prices that, so I can like present in that just like this value task वगैरह
As in,
just like this page, okay. And when I have a presentation in one thing and something about that one person, okay.
what do you want to present?
And any I think any presentation, sir.
So, you want to present a spreadsheet?
Yes, sir. So I calculate all these things, sir.
Yeah,
Only numbers, sir.
yeah, you can calculate these things. I mean, that depends whether you want to show directly result or you want to show the process of how you came up with the how you arrived at the calculation.
Okay, sir. Okay, sir.
Okay.
Yes, sir. Yes, sir.
All right. Rishabh, you have any blockers? You want to try it once again? We have a few more minutes.
Yes, sir. Yes, I tried, ma'am.
Okay, you can share your screen if you want. Rishabh, you want to share your screen? I think he left the meeting. Let us wait for a few minutes for him to join
Yes, sir.
before we call it a day. Yeah.